is a combination of medicines that can be employed for that. Rituximab is often used. That is an pre-B cell antibody to try to block the development of B cell clones that will eventually become plasma cells and produce antibody. Some centers, such as ours, will also use intravenous immunoglobulin, which creates anti-idiotypic antibodies that may shut down the production of either the B cells or the T helper cells that allow the B cells to proceed to maturation. Some centers will give additional thymoglobulin, which is a rabbit-derived anti-thymocyte globulin, as an adjunct therapy. It's not a primary therapy for AMR, but often there's a mixed rejection in play in those cases. And if these don't work on their own, some of us have utilized then additional therapies, one of which is a direct protease inhibitor which blocks plasma cells, and that is called bortezomib. Again, the results with bortezomib have been somewhat mixed. And then eculizumab has been tried in some cases, again, in the hope that we can block the terminal effector complement pathways.
You mentioned eculizumab, and we will come to that also in a moment. So I will ask you some more questions there. But before we move on, if you would think of antibody-mediated resistance as an indication, how would you describe the medical need? Is there a significant medical need, or where is it? Is it the effectiveness of the treatment? Is it more the side effects?
I think there's a significant medical need for effectiveness. One, the therapies that we use are not fully effective, and they do carry a fair amount of side effects. Plasmapheresis is a procedure that involves then placing what is called a central venous line in the patient and then hooking up the patient to a machine. The other therapies are mostly injections, and they come with their own side effects. Rituximab, generally well tolerated, but does have a risk of progressive multifocal leukoencephalopathy, which is a rare complication, but it is uniformly fatal when it occurs. Thankfully, I've never seen it, but I know of somebody who's seen it. And then, again, bortezomib and eculizumab have their risks. Eculizumab has a risk of meningococcal meningitis. And so each of these therapies carries some problems, and they may not be fully effective, and we don't know how much to be able to use and when we have really have we sufficiently treated it is hard to judge when that point is. The C4D staining will stay on the biopsies for quite a while. PSA levels can drop, but how much do they need to drop? We do not know the answer to that. So there is significant unmet need in this area.
And if I would ask you to quantify it from your perspective, from 1 being the lowest and 5 being the highest, and I understand that this is a non-scientific question, but I would just want to get a little bit of a feeling, where would you place the medical need in AMR?
I would say 4. I mean, it's not a situation where there is absolutely no drug available. Which, if had that been the case, I would have said 5, but the drugs are not where we would like them to be. So I think there is a high need, and I would use the number 4.
Thank you. And if I stay on that topic for one more moment, you said that the therapies are not always effective. Is that the efficacy in all of the patients is not very great, or is it that the effectiveness in a specific patient group can be very high, but it doesn't work in all patient groups?
I would say more of the latter. There are patients in whom it does work, and there are many patients in whom the therapies do not work at all, and we do not fully understand that yet.